So today we're finishing up our probability unit. And then we've learned so much probability. And then next week we'll review and test. So that's awesome, guys. There will be a lot of probability on the end of level test. But you guys have done really quite well with it. I've been very impressed. Because probability is one of the hardest things. I usually teach my students probability very last in the entire year. It's the last thing we learn before the end of the level test. It fell differently here at RHS. But you guys have understood it really well. So I'm very impressed with you. All right, so today we're just doing 3-6. We're going to be talking about expected values. So expected values is different than probability. We're going to use probability in expected values, but it's different than finding a probability. So what expected value is the amount you would expect to win or lose per game. So once again, expected value is the amount you would expect to win or lose per game. Now, once again, this value does not need to be a possible outcome, but instead reflects an average amount that will be expected to be won or lost. So once again, this is not a probability. This is an average amount we're going to be expected to win or lose. We will use probability with this, though. So hopefully you understand just what expected value is. I expect to win about $20 or whatever. So we'll get to that. All right, I'll give you a second. Some people are still writing. Here is the formula. So now we might be given more than 2 events, but we'll just add it on as we go. It's the same formula. You just keep going. So if we have 2 events, event 1 and event 2, we can find the expected value, how much you would expect to win or lose, by this formula. You'll take the probability of event 1. So you've got to find the probability of event 1, and then you'll multiply it to event 1, how much you would win from event 1. Then you'll add that up to probability of event 2 happening, how likely it is for event 2, times by what you would win if you did land on event 2. So this is the formula. And we could keep going. If there was a third event, we would just say plus the probability of event 3 times by how much you would win in event 3. Now, interesting enough, a fair game, if it's completely fair, you're going to have equally likely the chance to lose an amount of money. It's equally likely to how much you would win an amount of money. So a fair game will have an expected value of 0. So that's one thing to note. It's going to ask you that on the worksheet. It's going to say, what would make this game fair? And you're going to have to know your expected value would have to be 0. So it's equally likely to lose a certain amount of money as it is to win that amount of money. So that would be a fair game. Okay, so I'll let you get that down and then we'll just practice this. That's all we're learning today. That's it. All right, but if you don't let them know that you know this, so you're going to be really smart one day, go gamble and win a lot of money because you're going to be a mathematician from Miss Christensen. Yeah, unless you don't gamble. All right, so here's our first example. So it says, first of all, it says find the expected value. So we're given this little spinner here, and I'm telling you, if we spin the spinner, we have this half, you'll land on $20. If you land on $20, you get to keep $20. If you land on this side of the spinner, you're going to lose $10. So let's go through and find the expected value. Well, we need that formula. To be able to do it, we need the probability of landing on each section. So let's look at this section. This is half and this is half, right? So it's a 50-50 chance. Is everybody following? It's a 50-50 chance of landing on each spinner. So I'm going to say, well, we have a 50% chance of landing on $20 and a 50% chance of landing on negative $10 and losing $10. So now we know everything we need to know for the expected value formula. So expected value is going to be equal to, you take the probability of event 1, so let's start with $20. So the probability of landing on $50 is a 50% chance. So I'm going to type it in as a decimal. 50%. Then you multiply it to how much you would win if you did land on that piece of the spinner. So if we land on that, there's a 50% chance. If we land on that, we're going to win $20. And then plus, there's also a 50% chance of landing on the negative $10. So losing $10. There's my formula. Then you just use your calculator, plug it in. So you'll type it into your calculator, practice it, and how much can we expect to win or lose? It might be negative. That means we're expected to lose. So how much can we expect to win or lose? $5. Very good. So our expected value is $5. All right. So is it a fair game? Is it fair for us versus the person who's making you spin? No. Whose favor is it in? Ours, right? There's a more chance if you're expected to win $5. So it's not a fair game. If it was a fair game, our expected value would have been 0. All right. So now if we know that it's average, we'll average win of $5. So we'll have an average winning of $5. That's what expected value is. Now, how much would you expect to win if you played 10 times? Well, if each spin, technically you're expected to, the expected value is $5. Does anybody have any ideas of how much we would win if we played 10 times? 50. Good. You take your 10, you times it by 5, because our expected value is $5. So playing 10 times 5, we can expect to win if we play 10 times $50. Very good, Justin. All right. Okay, questions on that? Now, everybody look with me up here for a second. The reason this is the hardest one for students to grasp is because they look at the spinner and say, well, how is that possible? How can you win $5 if that's not even an option when you land on the spinner? But it's because we're not looking at the probability. We're looking at how much we can expect to win or lose. So what it's trying to say is, if we sit and spin the spinner, sometimes we're going to lose $10 and sometimes we're going to win 20. But because we're actually winning more when we land over here, we can expect to win an average of $5. Does that make sense? Not per spin, but just average overall. You can expect, so obviously, it's saying like, if we sit and play quite a few times, we can expect to win an average of around $5. That's why it's hard for students to grasp, because you can't, right, because sometimes you're going to land on negative 10, right? Then you're in debt. It doesn't matter. We can do 10. See, this was 10 times. This is how much we can expect to win if we do it 10 times. If we do it 2 times, we can expect to win how much? $10.
So that's just for one spin, an average for one.
Right. I guess you're right. That is it. Okay, sorry. Yes, that is true. It is an average per spin. Yeah. Okay. Any questions on that? Okay. Let's do another one. So find the expected value. So looking at this spinner now, there's a lot more options. This one takes a little bit more thought. So first of all, to find the expected value, we have to know the probability of landing in each section of the spinner. So if you look at this right here on this section, is what percent of the spinner? 50%. So I'm going to write 50%. Does everybody understand? 50%. Okay. Now this is the harder part. On this side we have 50 total, 50% total. But this is 35 degrees. This is 35 degrees. So this section right here, you guys, is taking up 35 degrees out of the total amount. So how do we find probability? So that's taking up 35 degrees of the total circle, right, everybody? So how can we find the probability? Good. You'll take 35 degrees and you'll divide it by the total amount, which is 360 degrees. That'll give us the probability of landing in that purple 35 degrees section. It's 35 degrees of 360, so there's that chance that we'll land there. So somebody tell me, what's the probability? 1.7? Oh, 1.79? Wait, what is it? 0.97. Oh, 0.97. So 0.97. So let's round. How about let's round to the nearest whole percent? So let's do 10%. Okay. Yeah, very good. So let's round to the nearest whole percent. So this is a 10% chance of landing in this purple section. All right. Well then, what percent chance are we going to land in this $3?
40.
Good. You take 100%, subtract 50, subtract 10, and you get 40%. Very good. So there's a 40% chance of landing on the $3. Now we have all the probabilities, so now we can plug it into our formula. So the expected value formula is equal to, so you'll take your probability of landing on each section times by how much you would win. So there's a 40% chance we'll win $3, plus there's a 50% chance we'll win $0, plus there's a 10% chance, 0.10, that we'll win $1. $1. So go ahead and calculate that. And do you get a dollar? 1.3, so that's $1.30. So we get 1.3, which is equal to $1.30. So is it more likely that you'll win or lose? Win, right? It's an expected value that after you've spun, that you'll average win, your average winnings will come out to be $1.30. So how much would you expect to win if you played 10 times? 13, good. You take 1.3 times 10 and you get $13. So why the heck wouldn't you play it? If you play 10 times, you're expected to win an average of around $13. And then 30 times, you'll take 1.3 if we spin it 30 times, and each spin will average win of 130. So 1.3 times 30, and you get $39. Very good. I definitely play that game. I'll take $39. You can't, you will lose. You can't even, yeah, Justin makes a good point. On this spinner, you can't lose. You just might not win anything, right? So it's not a bad deal. Yeah.
I'm wondering, is with games like this, you have to like pay to play them, so is it worth it? Like,
Right. So good point. So she presents a good point. So if so I guess it depends. Let's say for example, Elise presents a good question. If it costs you $5 to be able to play, because that's usually, I mean, they're not going to just let you play for free, win for nothing. So it depends on how many spins. So let's say it costs us $5 to each spin. I mean, with this average of winning $1.30, would it be a good idea necessarily? No. Yeah, you can't even win. You're right. You can't even win. That was a bad example, I guess. So let's say it was, $2. That was a bad example. So if it was $2 to spin, would you, because you could win $3, so would you want to do that? No, not with this expected value. So you could look and weigh your options. Yeah, that was a really good question. All right, let's do, I'll let you practice now. So do problems 1 through 7, 1, 2, 3, 5, and 7. We're skipping number 6. We're not going to do number 6. But number 3, I left off the picture, bless my heart. I left off the picture when I was copying and pasting and making my worksheet. So this is the picture you'll use for number 3. So I apologize. I would draw it on my paper so that you have it on there. So once again, to find expected value, you have to go through, find all the probabilities, and then you just plug it into your formula. So then once again, if you had to pay a certain amount to play the game, if your expected value is higher than that amount, yes, I would play it. If not, you wouldn't want to play it because you're expected to make less than what you had to pay. So that's a good point. I'm glad Elise asked that. All right. Okay, so everybody, you'll definitely want to watch this because otherwise it's going to be hard for you, okay? So looking at this example, it says, for the spinner, determine the value for X so that the expected value of the spinner is 5. So this time we're not asked to find the expected value. If you look in here, we couldn't find the expected value because we have a variable in here. Instead, it says, given that the expected value is 5, So it says, given that, find the value of X so that the expected value of the spinner is 5. So we're given that the expected value is 5. So we know that the formula for expected value is expected value is equal to, and then we know that we do the probability of event 1 times by event 1 plus the probability of event 2 times by event 2 and so on. So let's go through and plug in what we know. Well, we need to find the probabilities of each event happening first of all. So let's find the probability of landing on this 3. So guys, think about it. If this is taking up 60 degrees out of the full circle, when we spin the spinner, what chance is it that we're going to land here? So you take the 360, the full circle, divided by, 60 divided by 360, and you get 1.66 repeating, so let's round to the nearest whole percent, so that's 17%. There's a 17% chance of landing in that section. 0.1, yeah, perfect. So 0.1666, so let's round to the whole percent, so 17%. Now, once again, right here, if this is 24 degrees, that's 24 degrees out of 360 degrees. So you'll take 24 divided by 360, and we'll round to the nearest whole degrees, so that'll be whole percent, so it'll be 7% chance, right, everybody? And then from here, this is the trickiest part, I guess, for most of you guys. So, what degrees is this? How can we find it? Degrees. Oh, we could just do percent. Why not just do percent? Good. Kel is awesome. You're right. Let's just do percent. Why not just do percent? So we could take 100%, subtract 17%, subtract 7%. What do you get? 76%. Very good. So there's a 76% chance of landing on this section. So now let's plug it in. So if you read it, it says the expected value of the spinner is 5. So we're given that this is 5. Does everybody understand that? So we're given 5, and that's equal to event 1. So I'm going to go with this. So 0.17 is the probability times by event 1, what you would win, which is 3, plus the probability of event 2. So 0.07 is 7% times by -2. And then plus the probability of event 3, so 0.76 times by x, right? What we would expect to win if we landed here, which is x, right? Now look in this problem. Do we only have one variable? Right there, it's an x. So now we're just going to algebraically solve for x, right? Yeah? Is everybody okay with that? Okay, so now we got to get x alone. I'm going to simplify this. What is this? 0.17 times 3. 0.51. Okay, and plus, what is this? Negative 0.14. And then we have plus 0.76 times x, right? That's 0.76 times x. All right, so then let's add these up. What's 0.51 plus negative 0.14? Add this up. I'm combining my numbers. 0.14. 0.37. So we have 5 is equal to 0.37 plus 0.76x. Now to get x alone, what am I going to do? Good. Minus 0.37 from both sides of the equation. Right? So then that's gone. So you'll do 5 minus 0.37 and you get 4.63 is equal to, and we still have 0.76x. Now to get x alone, what's my next step? Good. Divide both sides by 0.76. So then it divides out over here. X is alone. So x is equal to 6.1. So $6.10, right? $6.10. So x would be equal to, if we need the expected value to be 5, x must be equal to $6.10. Very good. So does everybody see how I did that algebraically? Wait, it was backwards, right? And then we had to use algebra to get x alone. Okay. So now you'll do problem number 6. So problem number 6 is just like that. While it's fresh on your brain, I'd at least practice at least one of those before I return to the old problems.